and they put it down using an asphalt paving machine. And then right behind that, you just put a 10-ton roller on it and set it in place. So it's just, you can utilize asphalt paving equipment to put this material down. It's you can put traffic on it in about 10 hours. It's tough as nails. You don't have to have forms. You don't have to saw it and put joints in it like we saw out on the interstate earlier. It's a tough load-carrying mix that you can get for a very low dollar.
South Pittsburgh revealed a town that was modernized through the judicious and aesthetically pleasing application of concrete, providing a valuable insight to the team of how the Bridgetown redevelopment project can be enhanced by the use of this dynamic material.
The street you're standing on is a concrete street that was about 100 years old that had been overlaid with asphalt, and so they came back and took all the asphalt off, took and put 1 inch of asphalt overlay on top of it, and they had built it up beyond the gutters. So we came in then at that time and put 4 inches of what we call ultra thin white topping on top of the 1 inch of asphalt, which is cut in 4-foot squares. And then after we did that, they came in, the city came in and added curbs and new sidewalks, and the colored concrete that you see, which looks like brick pavers, is actually concrete that's been stamped to look like brick. And the little city has been revived. It's an altogether new look for this little town, and I think it's helped it tremendously.
This town has also been a pioneer in terms of the use of concrete, and an example of how durable this material is.
We're looking at some streets that are about 94 years old now. They were put in when South Pittsburgh was going to become the steel production center of the South. A new cement plant was built here, and iron ore was discovered, but the iron ore soon ran out, and steel production went to Birmingham, Alabama. But this town had concrete streets, it had concrete houses, had concrete fences, and a lot of those things are still standing here. And as Jack is shooting the streets, you can see 94 years old. Now, Bob, we need your comment now about what's not here.
There's no potholes here.
The experiences of the authorities in Tennessee in repaving Interstate 40, a busy highway dissecting the state from west to east, hold valuable lessons for local authorities in how concrete can be applied on major highways like the ABC.
This particular section you're looking at is concrete pavement that was placed in 1997. The pavement is 9 inches thick, and it is placed on, initially the pavement was 8 inches of concrete placed on cement treated base, and there was no load transfer. The old pavement lasted 34 years. We came in and repaired the sections that were broken up, overlaid it with 1 inch of asphalt to have a bond breaker, and then we placed 9 inches of new concrete on this pavement in 1997. The rideability is, if I'm remembering correctly, is 2.75 inches per mile, roughness index based on a profilograph. The requirement was that we beat 7 inches per mile, and I think it's probably as smooth as any asphalt pavement going. The one side has a 4-foot concrete shoulder, the other has a 10-foot shoulder, and on both sides we put rumble strips to wake up any sleepy driver. It's heavily traveled in truck traffic. The asphalt pavement is continually being redone in all of these areas because of the rutting and the hydroplaning. And we feel like that hydroplaning is what's killing probably a great majority of the people in this country, because when you get ruts and you get water in them and people hit it, they no longer have control of their vehicles. But we think this section will be here for 30, 40, 50 years, just as you see it today. And as you can tell in the trucks that are passing and the cars that are passing, it's a pretty smooth pavement.
But despite their overwhelming endorsement of concrete, having successfully applied it for several decades, these intrepid Americans are leaving nothing to chance, and are literally making a science out of the study of concrete versus asphalt by rigorous and constant testing.
The asphalt side is a test section as well. They put down what they call super pave on that side, and they're testing. Over the next few years, we'll be testing how the rideability and on both sides hold up, one compared to the other, and also how long each one will last compared to the other, so we can better determine what the life cycle cost is on pavements rather than just what it costs to put it down.
The lessons gleaned from a visit to Savannah Harding County Airport can prove invaluable if applied to local conditions when the time comes for future repairs to our airport.
This is the first time that this has ever been done on the runway. It's called an ultra-thin white topping, and it's absolutely gorgeous. As you fellows seen when we were going down through there, it's white, and again, it's the first time that it's ever been done in the nation, and we're kind of proud of it because of being the first one, and so we're having an air show to show it off, and we're pleased, very pleased with what was done here. It's beautiful out there. The runway is absolutely just smooth as it can be. I have a little Cherokee 140 that I taken up and land out there, and it was the smoothest thing I'd ever landed on. It's absolutely gorgeous, and we're thrilled to death with the new runway, the apron, and the taxiways that are here.
Homer Skelton, a pilot flying daily into this airport for years, can testify to the benefits of the new white-top runway.
It's like a different airport. I don't know anything about the tap concrete they put over the blacktop, but it looks great, and I would imagine it'll last 40 or 50 years. So I think they made a wise decision by doing that. Before it was quite rough. I have a King here, and I was a little reluctant to bring it in. It got beat up pretty good, and so I'm real happy that they did that.
Tennessee has been in the forefront of utilizing concrete technology for its major highways, secondary roads, and airport runways. In more ways than one, the trip was an eye-opener, as engineers and contractors received first-hand information not only on the durability and cost-effectiveness of concrete as opposed to the traditional asphalt, but also on the application methods and type of equipment used. Like those in Tennessee, we at Arawak take nothing to chance. That's why we are exposing our local engineers and contractors to the wider world of concrete, so the facts can speak for themselves. And that is why we have unequivocally accepted the challenge thrown out by Prime Minister Arthur to assist government in finding mechanisms and financing to help make concrete roads a reality in Barbados. But let's hear the views of these engineers and contractors, which speak volumes for the use of this material to help solve this country's road problems.
This has been a very productive trip in that it's allowed us to see over the 3 days hundreds of miles of concrete roads and runways, and also to have discussions with officials from the American Concrete Paving Association and local contractors with a view to coming fully to grips with the whole issue of the design and laying and maintenance of concrete roads.
The range of applications that we saw would be useful in Barbados depending on the locations that we're dealing with, whether they be highways or feeder roads. And I think another application which we saw of concrete in a parking area and concrete on a road shoulder are also applications which will have some part to play in future road construction in Barbados.
Their use of the ultra-thin concrete roads, thicknesses of 4 inches and under, and also the compact rolled concrete rolls, I think are particularly relevant to our situations where we are doing small-scale works.
Everywhere we went and every concrete project we saw was interesting because they were all different, and that was the interesting part about it, is that all of them were different, and all the applications were different, and all the concrete designs were different, and it has certainly given me a broader base to think of with concrete. And I think we should be thinking more about it at home, and I am hoping that this will not end here. I'm hoping that we will go back home now and try to design and fully think about it and see what we can do to try and bring it into Barbados. We have concrete there already. There's no reason why we shouldn't be using it more. The application of roads, although we have done some, has been very on a very small basis. And I think that the time has come now where we should start thinking, because there are certainly applications in roadworks at home where we could apply a lot of what we saw today.
The distinct advantage of using concrete roads for us would be that we would reduce the life cycle cost of the roads and reduce the maintenance considerably, and in so doing take some strain off the scarce resources, human and financial, that we presently have to apply towards the maintenance of our 600 or 700 miles of roads nationally.
Now that we are back here in Barbados, I am particularly pleased to see that the Prime Minister has announced a $40 million program to build tenantry and subsidiary roads out of concrete. I would be particularly pleased too to see that as we develop that program, that we are working in parallel with that program to develop one for the expansion of the ABC Highway. We said back in 1999 that we believe that the widening of the ABC Highway is an ideal opportunity to use concrete on our highways now. And though the tenantry roads is a start, I would expect that we will be going farther and will be developing concrete roads for our highway applications. There will still be uses for asphalt, but I believe that on our highways, that is where we will get the maximum benefit for concrete roads.
We can boldly state, without fear of contradiction, that concrete will be value added in this paradigm shift. It is durable, versatile, the material of the 21st century for concrete solutions.